Okay, great. Yeah, it looks like we are live. I'm going to go ahead and check out Twitter to see if this also got posted there. Yep. So we're good to go. So for anyone watching, we're going to spend the next 30 minutes chatting with the founders of Authentic. And this is going to be the first of many of these types of ephemeral, quick series that we're going to be doing, diving into not only teams building within the EigenLayer ecosystem, but just people building really cool stuff in the Web3 ecosystem. But today we are specifically talking about AVS development. And we're talking about it at a time when there's a lot of interest. And I think the product and the solution that the Othentic team has is really, really relevant for anyone looking to build. And I think it's a good topic. So with that, we will go ahead and introduce Yarden. Do you want to give us a quick intro and also maybe an introduction to what Othentic does?
Oh yeah, definitely. Thanks, Nader, for having me, for having us. So my name is Yarden. I'm the co-founder of Othentic together with Tim, my CDO. My background is in venture capital. Basically, 5 years before building Authentic, I used to work as a venture capital investor, mainly investing in early stage software-based companies. Beforehand, I used to manage an accelerator in partnership with Microsoft. And I got into crypto somewhere around 2016-ish, while I was working as a business development for a protocol built on top of Ethereum. So Ethereum was initially my first dive into this, rabbit hole, into this complex ecosystem of blockchain. And since then, it was my night job. And a year and a half ago, Dean and I, we dropped off previous jobs, basically with this passion to build in the Web3 blockchain space. And this is where we start building the Authentic.
Awesome. So can you give a TLDR or an elevator pitch for what Authentic is and does?
Simply put, Authentic is a self-deploy infrastructure to spin up AVSs on EigenLayer. Imagine it as a library of production-ready components where AVS developer can take what we already built, like a pre-built components, configure it according to its own need, and basically to spin up his own unique AVS with his own specific, basically novel computational service, simply put.
Cool. Yeah, I think that one of the things that we're realizing is that the demand for building AVSs outweighs the supply of resources that are there right now. So we're really looking to expand the breadth of how people can get started, lower the barrier to entry. And I think Authentic is like obviously a really good place to consider building if you're kind of wanting to build an AVS. But I'm curious, how did you all kind of get into this vertical, considering how new it is? And how long ago did you start building this? And like, what made you realize that this is what you wanted to focus on in terms of like realizing potential there and potential growth in this entire restaking AVS ecosystem?
Oh yeah, definitely. Basically, EigenLayer and basically the novel primitive that Eigen provide by inheriting the Ethereum L1 security to provide stronger crypto economic security to individual services, basically significantly increase the trust guarantees to this individual service and create a flourish environment for permissionless innovation. And that's basically we started off as a team. We started off by building an AVS almost a year and a half ago. We called it like a decentralized service. And we all know, like back then, bootstrapping security for a network and basically to build a new trust layer, it was like a tough mission. And we got to know EigenLayer and basically to spin up our own AVS. And we did it for something like 6, 7 months. And during this time, we basically understood all of the complexities, all of the bits and bytes, all of the difficulties that other builders will have to face while spinning their own AVS. Basically, instead of working on our core protocol, on our core service, we were busy developing low-level networking infrastructure, networking components, a consensus engine to come onto agreement on specialized node client task. And basically, we realized that if we as a team needs to develop it on our own Any other builders will have to do the same, basically spin up his own network in this new shared security environment. So we thought ourselves, okay, let's make it available to any other AVS builders. And Othentic basically is on a mission to enable the creation of novel computational services by providing this self-deploy infrastructure to spin up systems with underlying shared security. So this is where basically we got to know Eigen and got to know the AVS landscape.
So if someone wanted to use Authentic, what types of services and networks could they build?
Maybe I want to maybe take a few step backs and maybe talk about the challenges for AVSs, and basically in that perspective we can dive into how Authentic basically contribute to the shared security ecosystem and what the Authentic stack provide to the EigenLayer ecosystem, if that's fine with you.
Yeah, that's actually really good. Let's dive into that. Yeah, so what are the challenges? So what have you seen in your own experience, but also like a lot of your customers? You seem to have quite a few teams building AVSs with you.
Yeah, definitely. So basically, while EigenLayer provides the fundamentals, basically the fundamental layer to inherit the Ethereum L1 security, the AVS developers, the developer is responsible for customizing a system, basically that interacts with EigenLayer smart contract framework, and also to develop many missing core components that fit the new shared security environment. And maybe let's dive into a quick breakdown. So first one and foremost is that Node's clients are continuously evolving. In this new shared security environment, a Node client needs to support novel use cases, and operators are required to execute diverse on-chain and off-chain computational tasks. Task is basically a compute unit to be carried out by the network operators. For instance, executing specific computation, attestate on the result of the computation, participating in dispute committees, syncing DA layers, monitor a transaction for other networks, retrieve information for different data sources, relay encrypted messages, index and query databases, even run verifiable provers, and many other use cases. So Node's clients need to support this basically innovation. Another thing is that the model of operators is being changed from being one-to-one, meaning one operator will validate one network. The approach and the model is changing to become one to many, which creates a new need for coordinated slashing mechanism across multiple AVSs or multiple networks, meaning to maximize rewards, of course, a single operators might opt in to validate multiple AVSs, and operators are of course penalized and for missing attestation, late attestation, and incorrect, or basically by violating a consensus rule. So basically, if they get slashed on one network, it should affect all of the other network as well, meaning their influence over the consensus process should be determined by the effective balance on the EigenLayer network. So this is like in high level. Let's talk about like AVS specific component that needed to be built in order to spin up an AVS. So first one is AVS developer needs to deploy their core service on top of trustless execution environment. They need to spin up a network of operators that execute unique task, unique computation, basically. They need an infrastructure to submit and audit the operator work. They need a consensus engine to allow off-chain execution and on-chain validation, right, to support those off-chain computational tasks, and also to attestate on the results of the executed task. They will also need an infrastructure to distribute rewards event and enforce penalties and slashing based on the operator's attestations. And so they also need like some sort of like a configurable rewarding mechanism. And they need a configurable node quorum. Let's say an AVS will have 400 different nodes that as part of his validation semantic is part of validation set, but in order to approve a task, only 40 is needed. So also like a configurable node quorum. Just to recap it all, AVS developers need a framework that support novel computational services, and AVS should focus on their core services instead of the development of low-level component, and this is exactly where Authentics comes into play.
Very cool. It sounds like you're following the evolution of all software, making like an abstraction just to kind of allow developers to focus on like essentially the cloud. When I was working at AWS, that was kind of a similar model. We want to make it to where you can focus on building out your core business logic, the differentiating features of the thing that you're focusing on, as opposed to all of the underlying infrastructure that just needs to exist in order for that to happen. So essentially, maybe teams can iterate faster. They can ship more quickly because they're not worried about all this underlying stuff. What types of like programming languages can people build with on Authentic? Can they just essentially write anything that they want as long as it's some type of off-chain service that is making calls back to the contracts that you all enable, or is there more to it?
Oh, so definitely yes. I will start maybe from the beginning. So what is the Authentic stack basically? So yeah, as I mentioned before, a library of production-ready components to spin up AVSs, but the Authentic stack basically orchestrates and abstract this new shared security primitive and allows basically AVS developer to self-deploy, which is super important, self-deploy a custom computational service over trustless execution environment and to spin up their own network of operators that run any type of arbitrary compute task. So basically, this is what we do. We let AVS developers to focus on their core service, to minimize engineering overheads and abstract away all of the low-level, error-prone infrastructure details. What we built is a framework. We call it a framework for stateless rollups. So what are stateless rollups? They are basically computing network that provides services to other networks or other applications without being constrained by any particular blockchain. They don't act just as a scaling solution to Ethereum, rather act as a decentralized computing network that are backed by a strong crypto economic security as for Eigen. And stateless rollups do not maintain any state themselves. They behave, you mentioned AWS. So they behave like Lambda functions on AWS, where they can execute these computing tasks and send back the results with something that we call proof of task. Yotam from our team will break it down in a bit. But one of the defining features for your questions, one of the defining features of stateless rollups is the versatility across various programming languages, where AVS developers can program according to their own preferences, including Python, JavaScript, Go, Rust. They can basically choose according to their own preferences. And as for the use cases, basically the frameworks facilitates the creation of coprocessors, ZK provers, privacy-preserving compute, decentralized order book, decentralized solvers, exploit prevention system, and many other novel services. And one of the core components of the stateless rollup framework is the consensus engine, basically to come onto on-chain agreement on any type of off-chain computation, on off-chain production. So this is like a brief overview what Authentic Stack is and what is stateless rollups and what we as in Authentic provide as a framework.
Very cool. Yeah. So I think that I'm curious right now around what are some of the different use cases that people are building with you right now, and then like maybe what are some of the things that you think could be built that haven't really been maybe explored yet in the AVS ecosystem?
So I just mentioned like the like use cases that are being built with us with Eigen. So starting off from oracles to exploit prevention system, authentication and access control network, encrypted messaging, FAG, AI inference. And as a team, we just love to think through like the underlying AVS design and work hands-on with AVS developers, because we get to see like so many innovation basically emerging on Eigenlayer, and this is super exciting.
Very cool. Yeah, I think that out of all of the different products and projects that I've seen building in this space, the thing that we again really need are just making it easier for people to kind of build and get started building AVSs. So it seems like a really good fit for anyone that's considering building an AVS to kind of reach out to you all and learn more. So I guess like if someone did want to build with Othentic, is it a permissionless process? Can they just go to your website, download an SDK and start building, or do you typically meet with the teams and kind of work together? What's the process look like? And I'm curious if it's going to change as you scale this up. Maybe you see that there's so much going on that you can't give as much time and effort to each team. So maybe you continue abstracting away a lot of that by building better tooling. But yeah, curious like what it looks like today to build an Othentic versus maybe what you want it to look like a year from now.
So one of our top priority is basically reducing risk in this new risk-taking economy. Okay, we as an enabler for innovation, it can basically goes both way. Okay, so we drive to work with a well-versed team that basically have in top of their mind the risk-taking risk and do not want just to ride on the narrative. So this is like our first mission. Down the road, of course, everything is going to be open source, everything is going to be permissionless. Right now, what we provide is basically an access to our GitHub repositories and an access to our CLI interface. So we basically compiled everything I just mentioned into a CLI interface where AVS developer can self-deploy, configure, test, and run his own AVS. So this is how we work right now. Currently, we are working with 20 AVSs in different design stages. And yeah, this is like, as you mentioned, we are full capacity and we try do our best to hands-on work with those AVSs. So this is why we are maybe being a bit slow on that front. But again, because we do want to minimize risk and we don't want to have this, there are so many like risk in this new risk-taking environment, and we as an enabler want to reduce them. So yeah.
Cool. That makes a lot of sense. So do you want to, I think we have another guest that we wanted to bring on. Go ahead and bring, okay, cool. I'll let him introduce himself.
Yeah, thank you so much. Excited to be here and thank you for inviting us. So yeah,
I just like a quick introduction.
Yeah,
so Tom is one of our core developers. And one of the things, so we mentioned slashing and risk and how basically it works. I thought Yotam can basically walk us through a deeper dive into the consensus engine for those specialized tasks for off-chain computation. So sorry, Yotam, yeah, please.
Yeah, thanks. So as Yarden said, I'm a core engineer at Othentic, and I will just share my screen. I know maybe some people are listening through Twitter, so they can't see the screen, but I hope that my explanations will also work without it. So
yeah, it should be on Twitter also. The video should be on Twitter.
Oh, really? So yeah. Nice. So Twitter also supports video. Cool.
Yes.
Okay, so I'm just sharing my screen. Thanks, Nano. So yeah, so basically Othentic lets anyone easily leverage eigenlayers, shared security, and build AVSs for off-chain computation. Okay, Othentic provides the core building blocks that any AVS needs, and it includes stuff like stake-weighted consensus mechanism for the operators, configurable slashing condition and rewards, like Yarden mentioned before. And Othentic bridges the gap between eigenlayers on-chain protocol and the AVS's execution logic that sits off-chain. with Othentic, you can write your AVS logic in whatever language you want. So now that you mentioned it, you asked about it before. So yeah, you can write your own logic in whatever language you want. Excuse me. And you can configure your interaction with the eigenlayer protocol in however shape you want to the smallest details. So I will quickly go over, and this is what I'm sharing on the screen, but I hope it will, we said that it's also on Twitter, so great. So what I'm sharing on screen, I want to quickly go through how the flow of a task might look like on an AVS built using Othentic. So we have the task performer, who is also an operator, and they perform some off-chain computation, and they submit a proof of task that Yarden mentioned before, and they submit it to the network. The task propagates through the P2P layer, which is implemented by the Othentic stack. Basically, every AVS operator, they run an additional service that we see here as the AVS Web API. And that additional service runs the validation logic of the AVS. Now, this is somewhat reminiscent of how Ethereum validators work, where they have to run, so an Ethereum validator has to run both an execution client and a consensus client. So it's slightly reminiscent of that setup. And the AVS Web API, as I mentioned, it can be written in any language, and it communicates with the P2P layer via some interface. It could be HTTP, gRPC, or WebSockets. The proof of task can be anything that the network that the AVS defines. It will have to represent the actual proof that the task was performed, and that depends on the type of task. There are different kinds of tasks, so you'll then mention a couple of use cases. So tasks could be, we usually categorize them into deterministic tasks and non-deterministic tasks, where deterministic tasks are stuff like, for example, if I have a shared prover and I need to verify the ZK proof, then, for example, the proof of task can simply be the ZK proof itself. There could be non-deterministic tasks, for example, such as a price oracle, where someone submits a price, and then all the validators, they have to see that the price is either within a range or the median of the, or they take the median of the all of the attesters in the network. So there could be different types of proofs, and the proof can be basically anything that you want. Once a task is submitted, the AVS nodes, all the AVS nodes, they take the proof of task, and they validate it through the AVS Web API, and they attest to its validity. One of these nodes will act as an aggregator, and this is similar to the attestation committee in the Ethereum consensus mechanism, and will aggregate all of these results into a special stake-weighted BLS signature. The Othentic smart contracts, okay, which you self-deployed, as Yarden mentioned, so these contracts are not controlled by Othentic, but you self-deploy them onto the network for your AVS. So the Othentic smart contract, they will validate the signatures, and they will make sure that at least 66% of the voting power attested to the task. And if the attesters, if they approve the task, then rewards will be distributed via the eigenlayer protocol on chain. And if the attesters rejected the task, then penalties will be slashed from the eigenlayer operators, again, via the eigenlayer protocol. All the rewards, penalties, and slashing conditions are all configurable, as Yarden mentioned before. So that's basically the high-level overview of the idea. There's obviously much more, and I can talk so much about all the details of the consensus and the P2P layer and how it communicates and all of that. But I hope that this gives a good overview of what Othentic provides for AVS builders.
Yeah, this diagram is great. Is this diagram on your website or part of your documentation or anything like that, if someone wanted to kind of go back and review this?
Yeah. So we have our docs website, and there's this diagram. There's also a more detailed diagram. This is like the the quick or like the simple overview of the stack. So we have a whole website with much more documentation, and we go into the details of exactly how the mechanism works and how the AVS logic communicates with the P2P layer and all of that stuff. And obviously, I didn't go over all of the capabilities that our smart contracts provide, but there are many, many capabilities that we provide out of the box with our smart contracts.
No, this is really helpful and a good start.
One thing that I want to emphasize and maybe recap with is, as I mentioned, as Yotam mentioned, everything is self-deploy. Okay, we are not a network, we are not a blockchain. There is zero reliance on us as a middleware, and this is the beauty of it. So basically, the AVS control its own validation semantic. It controls its own network functionalities, and this is the beauty of it.
So I guess if someone is watching, we have to wrap it up in a couple of minutes. What would be the easiest way to get started building with Othentic?
So yeah, you can approach us on Twitter, to our website, and we would love, as I mentioned, we would love to think through like AVS designs. We are always available to brainstorm, even with more advanced, more mature. There is a long tail, basically, of AVS's established networks that are looking to migrate to Eigen, and more early stage startups. We are working with everyone, and of course, this is what we do for a living, and we love to do it. This is super exciting, basically, to work with those emerging and novel use cases.
Amazing. Yeah. So this has been really great. I've already learned a lot. So I appreciate you all coming on and spending your time with me today. And I think we're going to have you all back on in a few weeks, or maybe a month or two later, to actually build an AVS from scratch online, which is going to be like a lot of fun. And I'm excited about that. So yeah, that's it. So thanks everyone for checking this out. And we'll hopefully be doing a lot more of these live streams with different people building in the AVS and EigenLayer ecosystem. So with that, we'll wrap it up. Thank you.
Thank you, Nader. Thank you for having us.
Thank you for having us.